Okay, so today we're going to be solving linear systems. We can have linear systems in 2 variables, or in 3 variables, or in 4, 5, however many we want. So looking at this first one, this is just a linear system of 2 variables. And anytime I have a line and another line, this point of intersection, that is going to be the point that is the solution to both of these equations. So for this problem, I can see that the solution is going to be the point 2, 1. So whatever these equations might be, in fact, I can write these equations. I know that this one would have been y equals x minus 1 is this equation. For this equation, I can see that the slope is down 2 over 1. So this equation would be y equals negative 2x. The y-intercept appears to be probably 5. And so this should be the point that works for both of them. If I plug 2 in here, negative 2 times 2 is negative 4 plus 5 is 1. And if I plug 2 in here, 2 minus 1 is 1. So yes, those are the 2 equations, and that's the solution. Okay? So on a problem like this, I can graph them and find the point of intersection, and that's the solution. But I can also say, well, if y equals x minus 1 and y equals negative 2x plus 5, well, this y and this y would have to be the same thing. So I could have solved this problem by setting these 2 equations equal to each other with substitution. Again, y equals x minus 1 and y equals this, so therefore those 2 must be equal. So solving this, I would add my 2x, and I get 3x. I would add my 1, and I get 6, and there again I get x equals 2. So once I had x equals 2, I could just substitute it in, and I get the 1. Okay? Makes sense? You remember doing this in Algebra 1. Okay, instead of looking at this example, let's look at this one now. So suppose one of my lines looks like this, and the other line looks like this. What would be the solution if I had something like that? Right, this is no solution. And that's because they are 2 parallel lines. Parallel lines are never going to meet, so they will have no solutions. The other case could be something like this, where one of my lines is y equals x plus 2, for example, and my other line is 2y equals 2x plus 4. What's really true of these 2 lines? They're the same, aren't they? So if I were to graph these 2 lines, my first line would look like this, and my second line would look like this. So what's the solution? Infinitely many. Now, when we say infinitely many, that doesn't mean that every single point you can think of is a solution, but every single point on this line is a solution. So any line, any point like 1, 3, 2, 4, 5, 7, all of those are going to be solutions. Okay? So we basically already went over this. All right, so now we're going to go to our extra practice. Let's look at page 20 down here at the bottom. I don't think we need the vocab on this. So to solve a 3-variable system, that's our goal for today. This is new. You've done the 2, but not the 3 variables. You're going to rewrite the linear system in 3 variables as a linear system in 2 variables by using the substitution or elimination method. Solve the new linear system for both of its variables. Substitute the values found in step 2 into one of the original equations and solve for the remaining variable. This is important here. When you obtain a false solution, such as 0 equals 1, in any of the steps, the system has no solution. So this is important. So we're going to have no solution if we get something that is not true. When you do not obtain a false solution, but obtain a true statement, such as 0 equals 0, or even something like 2 equals 2, as long as it's a true statement, then the system has infinitely many solutions. Okay? So let's say we go through a problem, working, and we end up with 5 equals 5 at the end. What does that mean? Infinitely many. We're working a solution. We end up as 5 equals 3. What's that mean? No solution. All right, now let's do some examples. It's on page 21. We're going to do numbers 1, 2, and 6. So looking at number 1, I'm trying to solve this, and I want to eliminate a variable. So I'm going to take any two that I can eliminate a variable from. So I'm going to use the first and the second. I can choose to eliminate the x's or the y's, doesn't matter. I'm going to choose to eliminate the x's. So I'm going to multiply my first equation through by negative 2. When I do that, I'm going to get negative 2x minus 4y plus 6z equals negative 22. I had to multiply that entire equation by negative 2. This is equivalent. It's the same as this one. It means the same thing. Now I'm going to rewrite my equation 2. My goal is to eliminate a variable. So when I add these two together, I'm going to get negative 3y plus 4z equals negative 13. Now what I'm going to have to do is use two other equations. I can't use 1 and 2 again. I can use 1 and 3, or I can use 2 and 3. And I want to eliminate the same variable. So what variable am I going to eliminate then? X. I'll go ahead and use 2 and 3. So what am I going to have to multiply my second equation by to eliminate my x's? Negative 2. So I'm going to multiply now my second equation by negative 2. So I'm going to come right here and I'm going to have negative 4x minus 2y plus 4z equals negative 18. Number 3, I don't have to change. And so now when I add these two, my x's go away. I'm going to have y plus 5z equals negative 2. So now what I have is, I have this equation and this equation. We're not doing number 5, so you can just exit out and continue straight down. So now with these two, I want to eliminate a variable. What would be the easiest to eliminate at this point? Y. And so I'm going to have to multiply my second equation by what? 3. So then I'm going to have negative 3y plus 4z equals negative 13. That's not going to change. On my second one, I'm going to have 3y plus 15z equals negative 6. I add these two together, I get 19z equals negative 19. So z is going to have to be negative 1. So now I know what one of my answers is. One of my answers is negative 1. What would I do now to find another answer? Go ahead.
Substitute negative 1 for z.
Right. So now we're going to go back and we're going to substitute in negative 1 for z. And I can plug it in anywhere. But here or here is going to be most helpful. I'm going to choose here. So I'm going to have y plus 5z equals negative 2. So y minus 5 equals negative 2. And y is going to equal 3. So now I know what y is. So now that I know what y and z are, I'm going to go and I'm going to plug in anywhere. I want to find out what x is. I'm going to choose to plug into the first one. We are going to do this one, so I'm going to come over here. So I'm going to have x plus, and then my y value is 3. So I'm plugging into my first equation. 2 times 3 is 6 minus my z is negative 1. So 3 times negative 1 is negative 3, but then that's going to be a plus 3. equals 11. So x plus 9 equals 11, and so x equals 2. And so now I know that if I have the point 2 for x, 3 for y, -1 for z, that's going to be the one that's the solution. That's the one point that will work for all three of those equations. You can see why you want to be very careful with your arithmetic. If you make one mistake, then all the answers are going to be wrong. The good news is, though, is if it's worth 6 points or something, I would only take off 3 points as long as you understand the process if you just make a small arithmetic mistake. But just try to be careful. Yeah.
Couldn't you just plug them into the graphing calculator and let that give you the answer?
The problem is our calculator can't solve in 3 dimensions, only 2. So since we have 3 variables, it's not going to work, unfortunately. Okay. You could develop a calculator that would do that. That'd be a cool thing when you have a real job. There are some things on the TI calculator you'll hear me say throughout the year, like, someone needs to find a way to do this. Like, this is one of the things they should find a way to do, because it'd make life a lot easier, wouldn't it? All right, let's go ahead and do the second one now. So we want to eliminate a variable. And so let's go ahead. You just want to stick with the x's. Looks like that's the easiest one. So I'm going to multiply this one by 2. And I'm going to get 2x minus 2y plus 6z equals 38. Second 2. And look at this one. See, I actually like this one. Does anybody know why I'm saying, ooh, look at this one? What's going to happen? What am I going to get over here? Yeah, go ahead. I'm going to get 0 equals, I don't even really care what that is. I know it's not 0, right? So 0 equals 47. And right there, I can stop. What do I know the answer is? No solution. So that makes it pretty easy right there. Okay, we'll do one more. Let's take this one, and I'll eliminate my x's by multiplying by -2. So just go ahead and kind of work along with me. Take the second one. And guys, I always eliminate my x's unless doing so is really difficult. If it's really difficult to eliminate the x's, then I'll go with something else. So there I used 1 and 2. So I can't use 1 and 2 again. I could use 1 and 3 or 2 and 3. Which would be easier, 2 and 3 or 1 and 3? Yeah, so I eliminated my x's for 1 and 2. I'm going to do 1 and 3 now. So now I'm going to multiply 1 by -3. Again, be careful with that arithmetic. Tell me if you see any mistakes, because I can make them too. All right, so this is what I've got. Everybody else got the same thing? Okay. So now I'm going to come up here because we're not doing this one, so we're just going to kind of wrap around back up here. So let's see, what's easiest to eliminate? Y and z is pretty equal. I think I'll do the y's though. To do the y's, I want to get a positive 10 on this one, so I'm going to multiply by -5. So now I'm going to have 10y minus 35z equals negative, what is that, 110? And here, oops, this is a z, not a y. So this is what, -21z, and this is, that would be -63. So this time I get z equals 3. Okay, so I've got z is 3. I can substitute in anywhere now to figure out what y is. Let's see the easiest place. This actually has smallest numbers, so I'm going to plug in, well, I can't use that. I have to use something that only has y's and z's in it. I can use this one. Let's use that one. So now I'm going to have negative 2y plus 7 times 3 is 21 equals 22. So negative 2y equals 1. So y is going to be negative 1/2. All right, so we've got y now. And then finally, I can plug in anywhere to find x. This looks the easiest spot to plug in for x. So I'm just going to come over here to my open spot here. I've got x plus 2 times negative 1/2 is going to be negative 1 minus 5 times 3 is 15. And so now I've got x minus 16 equals negative 12, and so x is going to be 4. So now we've got 4, negative 1/2, and 3 for our solution. Understand the process? It's just kind of tedious work on this kind of stuff. And you won't have more than 2 of these on your quiz because it takes a long time to do. It's actually your test, not a quiz. Okay, let's do this very last one down here. We're not going to go through the whole thing. All you would have to do on a problem like this is, yeah, sure. If you notice on your homework, not all of these are going to be that lengthy as the ones we've done, but especially 30 and 37 on your homework, it just says set up only. So that just means you're going to set up the equations. You don't have to actually solve. And that's what we're going to do on this one, is just set up the equation but not solve it. All right. So for number 7, it says you found $6.60 on the ground at school, all in nickels, dimes, and quarters. You have twice as many quarters as dimes and 42 coins in all. How many of each type of coin do you have? Well, we should probably write this out. Like, let's say x equals the number of nickels. Y equals, I'm just going in order, the number of dimes. And z equals the number of quarters. You can use any variables. If you want, you could use n, d, and q. My q's look so much like 8s, I kind of avoid using the q's. So I just use x, y, and z because that's what I'm used to using. Does anybody know of an equation I could write? There's 3 equations I have to be able to write because I have 3 variables. Anybody tell me one equation that I could write? Yeah, go ahead.
660 equals 0.5x plus 0.1y plus 0.25z.
And that's equal to 660. I agree with that one. So we have 1 down, 2 to go. Anybody know of another one? Yeah, go ahead.
X plus y plus z equals 42.
I agree with that one. Okay, so that would be good. Now we just need 1 more equation. And we would be able to solve it, but we don't have to solve it, but we could. Anybody know 1 more equation I could write? What would be the last equation? Read that second sentence. You have twice as many quarters as dimes. How would I write that? Yeah. Naomi? 2y equals z. Okay, so let's double check that. So that would be saying we have to double the number of dimes to get the number of quarters. Let's see if that's right. We have twice as many quarters. So to get the quarters, we have to double the dimes. Do we agree with that? Twice as many quarters as dimes? So twice as many quarters as dimes. C equals. Do we agree it's this way, or were some of you thinking this way? Which way would be right? The way she said is right? Correct. So a lot of people put it this way, but that's not going to be correct, because in order to make these equal, it says we have twice as many quarters as dimes, so however many dimes we have, we double those to get the same as the number of quarters. And that would be what I would expect to see on your test as far as just setting it up and not solving it. Now, if you had to solve it, you could just do it one step at a time. You would substitute in and just keep working that way. Okay? All right, guys, good job. Homework's on the board. It's the same as what's on your assignment sheet.